We're going to go over proof tip 6 with you guys, and with the topic being isosceles triangles. So there are two key theorems here. There's the isosceles triangle theorem, which says if two sides of a triangle are congruent, then the angles opposite the sides are congruent. So if I have a triangle, just one triangle, okay, it has these two sides congruent. Right, so if AB so if AB is congruent to BC, so two sides congruent, then in this picture, angle A would be congruent to angle C. Right, so that is what the isosceles triangle theorem is stating. Now the converse of that, or the opposite of that, is also true. So you could say you could start with the angles. If angle A is congruent to angle C, so if you have two base angles that are congruent in a triangle, then we can say it's an isosceles triangle, which means then AC is congruent to BC. So both of those are working. So you just need to remember that the isosceles triangle theorem, you start with an isosceles triangle, which means by definition, two sides are congruent. That's the definition of an isosceles triangle. So if you start with an isosceles triangle, then you get two base angles are congruent. And it has to be the angles that are opposite the sides. Right? So if you have a triangle that's where these two sides are congruent, so it's kind of an isosceles turned on its side, then its base angles would be these two, right? So it has to be the two angles opposite the two sides that are congruent. So those are the two theorems that we're going to use with proofs. And then there's a couple other statements here that we're going to use. It says, remember two angles that form a linear pair are supplementary. Okay, so a linear pair are two. So if I have a line, that's where it's linear, right? And two angles that form that line. So if I were to do something like this, angle 1 and angle 2, we'd say that angle 1 and angle 2 are a linear pair because together, sorry, I'll do a double arc there for 2, but together they form 180. Okay, and in the picture, it's actually a line. So supplementary means forms 180 degrees. Linear pair means two angles that make that straight line. And then supplements, so that's that statement. And then supplements of congruent angles are congruent. So if I were to extend this a little bit, so this is angle 3 and angle 4. So we could say that angle 2 is a supplement of angle 1. We can also say angle 1 is a supplement of angle 2. They're supplementary, which means they both add up to 180 degrees. We could say that angle 4 is a supplement of angle 3, right? And so if what the statement saying, supplements of congruent angles are congruent. So if I know that angle 1 and angle 3 are congruent, then their supplements will be congruent. So then angle 2 and angle 4 will have to be congruent. So that's the idea. Which makes sense. Like if you think about it, if angle 1, let's give a measure to it. If angle 1 were 100 degrees, and if angle 3 were 100 degrees, okay, they would be congruent to each other. Now, angle 2 would be a supplement of angle 1, which means they add up to 180, so that would make angle 2 80 degrees. Angle 4 would be supplement to angle 3. Angle 3 is 100, so angle 4 would also be at 80 degrees. And so now you see that angle 2 and angle 4 also have to be congruent to each other. So it's some fancy language, but the ideas are not too complicated. So again, two angles that form a linear pair are supplementary, and supplements of congruent angles are congruent. So we're going to use all these pieces in some proofs. So let's take a look at number 4. So here we are given some information, and we're given that, I'm just going to jot these down. So angle ACB is congruent to angle DCB. And I'll mark that in. ACB, so right here, congruent to angle DCB right here. And then angle CAD, so CAD right here is congruent to, should say, it was cut off here, sorry about that, should say CDA. Right here. And the reason is given. Okay, so our goal is to prove, and I'm going to highlight them, that ABC, this triangle here, is congruent to DBC, this triangle here. Okay, so this, what I highlighted in green, we want to show that those two triangles are congruent. Right now, all we have is an angle in one of them congruent to another, one angle in the other, which is not enough information. If we look at those two triangles, they share a side, they share BC. So I'm going to say that BC is congruent to itself. The reason is the reflexive property of congruence. And now we have, in each triangle, we have an angle and we have one side. So we still need another piece of information. If we look at the whole diagram, though, we see, if you look at triangle ACD, you see that two of the base angles are congruent. And if two of the base angles are congruent, we can say that that has to be an isosceles triangle. So we could say that AC is going to be congruent to CD. So that's what I'm going to write. AC is congruent to CD by the converse of the isosceles triangle theorem. Okay, Again, what does the converse say? It says, well, if you have a triangle that has two angles the same, if you start with that, which we did, then it's going to be an isosceles triangle. And that's how I got AC is congruent to CD. So you want to know what the theorem says and be able to use that. Now, if we look at our diagram, we see that each of those triangles that I highlighted in green have two sides and one angle congruent to two sides and one angle. So we could say that triangle ABC is congruent to triangle DBC. And the reason here would be side angle side congruence. Now, my statement 3 came from step 1, because in step 1, that's when we found out that our base angles were congruent. And statement 4 came from steps 1, 2, and 3. Right, because those were our congruent statements for the side angle side. And there's our proof. Take a look at one more, number 5. Start with our given. Angle ACB is congruent to angle DEB. And angle ABC is congruent to angle DBE. And that's what we're given. And we would like to prove that ACB is congruent to DEB. So the small triangle on the left congruent to the small triangle on the right. And right now all we have is two angles congruent to two angles. And the only way to prove those triangles are congruent is to get a side congruent to a side. So at first it may seem like, how in the world can we get a side congruent to a side? Well, if you think about what we're learning here, we're learning about the isosceles triangle theorem, the converse of the isosceles triangle theorem. If we can get an isosceles triangle here, we're going to get two sides congruent. So I'm going to try to show, if I could show that this triangle here that I'm highlighting in green is an isosceles triangle, then I can get BC is congruent to BE, which will help me with my proof. Well, how do we show that something's an isosceles? There's a couple ways, but I'm going to try using the converse of the isosceles triangle theorem. So I'd like to show that the two base angles are congruent somehow. So how do we do that? Well, I'm going to bring us back up to these two statements. So it says that two angles that form a linear pair are supplementary, and supplements of congruent angles are congruent. So here's my statement. And I'm going to put in some numbers here. I'll call this angle 1, angle 2, this will be angle 3, and angle 4. So my second statement is going to be angle 3 is a supplement of angle 1. And I'm also going to write angle 4 is a supplement of angle 2. And my reason is going to be that two angles that form a linear pair are congruent. Okay, again, a linear pair, so angle 1 and angle 3 are a linear pair because they form together, they form a straight line. Angle 4 and 2 are a linear pair because together they form a straight line. And so that's how we know they're supplementary. Also keep in mind angle 1 is ACB, so this is angle 1, and this is angle, and we already know angle 1 is congruent to angle 2. Angle 2 from my diagram is DEB. So then we can say that angle 3 is congruent to angle 4. Because if angle 1 and angle 2 are congruent, then angle 3 and angle 4 have to be congruent. So it's this argument over here where where'd it go? Right up here. Where I put some numbers in. I said, hey, if these two are 100 degrees, then these two have to be congruent. They both have to be 80 degrees. Same idea here, right? So angle 3 is going to be congruent to angle 4. And the reason is supplements of congruent angles. Okay, so angle 3 and angle 4 are the supplements, and they're supplements of angle 1 and angle 2. Angle 1 and angle 2 we know are congruent right here in statement 1. Okay, so supplements of congruent angles are themselves going to be congruent. Okay, so because angle 1 and angle 2 are congruent, and because angle 3 and angle 4 are supplements of those congruent angles, that means that angle 3 and angle 4 are congruent. So think through that. There's quite a bit of logic going on there, but this is relying on steps 1 and 2. Because step 1 says that angle 1 and angle 2 are congruent. Step 2 says that angle 3 and angle 4 are supplements of angle 1 and angle 2. And we're using those two ideas in conjunction just to make statement 3. So why did I do that? Well, now the triangle I have in green, I've just shown that base angles are congruent. So I can now say it's an isosceles triangle. I could say that BC is congruent to BE. By the converse of the isosceles triangle theorem. And that relies on step 3, because step 3 is what tells us that the base angles of that triangle are congruent. So now, step 5, not 4. We can go back to our original purpose, which was to prove that triangle ACB is congruent to triangle DEB. And we can say that they're congruent because of which shortcut? Angle, side, angle. And in step 1, we have both the angles, right? Angle and angle. And in step 4, we have the side. So a little more challenging proof here. Number 6 will be a very similar type of proof as number 5. I'm going to stop there.